This is how it looks inside our electric kettle when water is boiling. We might be thinking how the kettle knows when to turn itself off. We will learn how it works in more detail later in this video. But before that, let's see the traditional methods of boiling water from the last century ago. Boiling water can be done in many ways, even in a pan on an open fire. It uses the same amount of energy, no matter what method we use to boil water. Water is boiling when bubbles form within a liquid phase that turns into gas at 100 degrees Celsius. Around 100 years ago, a steam kettle was invented and used along with a gas cooktop. The working principle is simple. When heat is applied to the kettle, boiling water inside the kettle turns into steam. The steam is forced out through the lid, releasing a high-pitched whistle, alerting us to turn off the gas stove. However, open fire is less efficient compared to unclosed kettle, as heat escapes to surrounding and take more time for water to boil. Nowadays, steam kettles have been replaced with electric kettles. Unlike steam kettles, electric kettles use heating element that is directly immersed in the water. The efficiency is increasing by 50% compared to traditional kettles, as it is capable of boiling water in a couple of minutes. In addition, the electric kettle will shut off itself after water is boiled. Before we go further, let's look at each component of the electric kettle. From the top, there is an openable lid where water is poured into. On one side, there is a spout that focuses the pouring water and directs the flow as we wish. Opposite to spout, there is a handle that allows our hand grip and carry the kettle comfortably. A little switch located on the top of handle with on and off function. The main part of the kettle is the body where the reservoir of water is heated. It can be ceramic, glass or stainless steel. The key to an electric kettle is the heating element placed under the body. On one side, the red light indicates the kettle on-off switch. Down the bottom there is a power base connector with a cord to attach to a standard electrical outlet. An electric kettle works by using the heating element. When we turn the electric kettle switch on, the large electric current flows through the heating element. The heating element is usually made of copper or stainless steel and is designed to be submerged in water at the bottom of the kettle. As the element heats up, it transfers heat to the water, causing it to boil. All modern kettles switch themselves off automatically using thermostats. This keeps the kettle from boiling dry or overheating. Let's see how it works. The simplest thermostat is a bimetallic plate integrated with a mechanical switch. The bimetallic plate consists of two metal plates with different expansion rates. One plate expands faster than the other as the temperature rises. Since both plates are tightly bonded and curved in one direction, expansion at different rates makes the plates snap and flex in the opposite direction. Let's see the boiling water again. Boiling water creates steam that flows upward. A steam guide located inside the kettle handle channels the flowing steam through the thermostat. The hot steam makes the thermostat snap in the opposite direction. The flex metal is then touching the lever and switching off the kettle. The thermostat will snap back to its original position when it's cooled down. But what will happen if we accidentally switch on an empty kettle? There is no steam to flow through to trigger the thermostat. This situation can be worse if it catches on fire. To avoid this situation, there is another thermostat under the kettle body. This mechanical thermostat does not depend on steam to heat up its bimetallic material. It will be triggered by a temperature preset where small currents run through the thermostat. When it reaches the preset temperature, the bimetallic disc will snap and flex in the same way as the top switch mechanism cuts electrical power from the circuit. Usually, the bottom thermostat contains two bimetallic discs to ensure the safety of the electric kettle, which is very scientific and reliable to use. This is also known as the electric kettle triple safety protection principle. If you learned something and find this video useful, please like, share, and subscribe to help this channel grow. And don't forget to click on the bell icon to get new video updates. Thank you and see you in the next video.